Welcome to a new lesson. In this lesson we'll be talking about polynomials of the form ax squared plus bx plus c. Let's first talk about to recognize the form. In a previous lesson you're given questions that look like this, where the leading coefficient is invisible, that means it's 1, and then b is 4, and then c is 3. In today's lesson, we're going to be giving you values that have leading coefficient that's not 1. For example, 2x squared plus 4x plus 3 to factor. Let's take a look at our first example. Given the following binary multiplications, you need to expand. So 3d plus 4 times 4d plus 3. Whenever there is a space between the brackets, it's always multiplication. And the way we expand this, don't forget to have equal signs on the left-hand side, it is called an expression. We're going to be multiplying the first term by the first term in the second bracket, the first term in the first bracket by the last term. So let's do this first. 3 times 4 is 12. D times d is d squared. Then 3 times positive 3 is 9, and d times 1 is d, so we just write d. Now the next part is we're going to expand the 4 by multiplying with 4d, and then 4 by multiplying with 3. So now we are going to multiply. 4 times 4 is 16, and don't forget d. And 4 times positive 3 is 12. So we finish expansion. However, we always have to collect the like terms. In this case, the like terms are d terms. So we recopy 2d squared. And now we add 9 with 16, which is 15, not 15, but 25 d. And recopy the 12. And this is your expanded and simplified trinomial. Let's take a look at the next problem. We're going to expand and simplify. Notice now that we have a little bit more negative values, but the procedure is exactly the same. I'm just going to copy the first factor and then the second factor, not the seventh factor. Again, it's a good practice to draw the little arrows to show what you're multiplying. We'll do that first. Negative 2 times 7, it's negative 14, and don't forget the g. Now, negative 2g times negative 3g is positive 6, and g times g is g squared. The next part, we're going to multiply the second term with everything outside of the bracket and inside the second binomial. So 8 times 7 is 56, and 8 times negative 3 is negative 24, and don't forget the g. The next thing is we need to do two things. We need to arrange the expression in descending order. This means that we have to rearrange it. That 6g squared is first because it's the highest power. And then we'll copy the 14g and the negative 24g with the 56. Again, recall that if there's no power, g has a power of 1. And 56 has no power because there's no g. So now we're going to collect the like terms. Again, we're going to be looking at the g's to collect the like terms. We get 6g squared, negative 14 minus negative 24, which is negative 38g. And we recopy the 56. And this is our answer. Notice again the same procedure. Let's take a look at a different example. In this example, we're not going to expand, but we are going to factor. And we're going to use logic reasoning to find our answer. So let's take a look at our first example. The first thing you should always check to see if you can divide each and every term by a greatest common factor. In this case, you can't, because 4 is 2 times 2, or 4 times 1, and 20 is 20 times 1, 4, and 5. So we're looking for greatest, just factors of these, and 2 times 10, and 9 is 9 times 1, and 3 times 3. There are no common factors that we can divide 4, 20, and 9 by. So we tried. Then we're going to use the logic to find the answers. So what is logic? We're going to take a look at 4 and 9, the first and the last term, and we're going to find all the factors of 4 and 9. So 2 and 2 and 4 and 1, 3 and 3 and 9 and 1. And now we ask ourselves, what combination of the factors of 4 and 9 will give us the middle term, which is 20? Well, the combination is that we take 2, we multiply by 9, so 2 times 9, and we add 2 times 1. 2 times 1. This will give us 20. So how do we put that into our factor? We'll put the first 2's in both these columns. Then we'll put the 9's. Put the 9 and the 1. And why are you probably asking, why are we putting this 2 with this 9? Why do I put it right there? Because the 2 eventually will have to multiply with that 9. And then what's remaining is that we have to put the variable, which is the variable h. And of course, don't forget that we have to have some kind of sign, and both of these signs are positive, so we put a positive for both of these. The way we check this problem is by expansion, and we will get 4h squared plus 20h plus 9 when we expand it. So this is our answer. We're going to do one more by logic question. So we'll do part B. 6k squared minus 11k minus 35. Again, we ask ourselves what two factors will multiply to get this. So again, we're going to take 6, and we can take negative 35. And we ask all the possible factors of 6 and negative 35. So negative 35 times 1, 35 times negative 1, negative 5 times 7, and one more, negative 7 times 5 will give us the same result. And then we again ask what combination of these factors will give us negative 11. So we're looking for negative 11. So when we multiply 3 with negative 7, so 3 times negative 7, we'll get negative 21. And then when we multiply 2 with 5, so 2 times 5, we will get positive 10. And negative 21 plus 10 will give us negative 11. So this is what we're looking for. And I'm just going to make sure the colors are the same. Negative 11. So how do we put this into our factors? So again, we start with the 3 and the 2. So 3, and it's always opposite to the 2 because they're factors of 6. Now since the 3 is multiplied with the 7, we have to put the 7 opposite to 3 so it multiplies. So we put negative 7 on the opposite side in the other factor. And then what's remaining, we'll put the 5. And it's a positive 5. Then we fill in the answers with the case. Again, in order to, and this is our answer, in order for us to check our answers, we need to expand and simplify, and we will get 6k squared minus 11k minus 35. Another way to solve factoring problem by logic reasoning can be done, if you don't like logic reasoning, you could solve factoring by a form of decomposition. I'm going to be using decomposition to answer these two factoring problems. So let's take a look at the first one. So we have 3s squared minus 13s minus 10. And decomposition is used whenever the first degree coefficient is 3, 2, 1, or frankly anything except for 1. And always you should double check if you can factor out any common factors of 3, 13, and 10 out of all the all the terms. In this case, you can't. So then we're going to use the process of decomposition. The process of decomposition starts like so. We ask ourselves what two values add up to the middle term, which is negative 13, and what two values multiply to get the multiplication of the first and the last term, which is 3 times negative 10, which is in this case negative 30. That's negative 30. So we multiply the first term and the last term together. And then a quick way to find these two values is to ask yourself about the factors of negative 30. We have 3 and 10, or actually 3 times negative 10, negative 10 times 3. We have 5 and 6, negative 5 and positive 6, or we have negative 6 and positive 5. And these are all the possibilities. There's also 15 times 2, and one of them is negative, and 2 times negative 15. And which of these will give us, when we add them, negative 13? And the answer to that is 2 and negative 15. This means that it's 2 times negative 15 will give us negative 30, and 2 plus negative 15 will give us negative 13. So let's continue on. So when the word decomposition comes to be, we're actually going to break down the 13 into 2 and negative 15. So we're going to recopy the 3s squared, and we're going to break down the 13 into positive 2s and negative 15s. That's going to be broken down into those. That's why we're doing this addition multiplication thing. Then we're going to recopy the negative 10. Now, this is probably a little bit harder than usual. We're going to factor by parts. That means we're going to factor the first two terms, and then we're going to factor the second two terms, or actually the second pair of two terms, separately. How do we factor? Well, we ask ourselves, what can we factor out of the first two terms? We can't factor a 3, we can't factor a 2, but we can definitely factor an s. So we can factor an s, so we get s, 3s plus 2. And how do I do that? Well, let's take a look at this in the right corner. 3s squared divided by s plus 2s divided by s. To factor them out, s squared cancels the s, and the s cancels the s. So we get 3s and 2 remaining. Of course, we still have to have the factor out of s out. The next step is to factor the other pair. What can I factor out of this? We could factor out a negative 5. So we could factor negative 5, and we'll get 3s plus 2. And how do we get that? Well, let's take a look at the right corner. We have negative 5, negative 15s minus 10. We divide by negative 5, and when we do this, we will get negative 15 divided by negative 5 is 3s. Negative divided by negative is a positive, and 10 divided by 5 is 2. And of course, since we are factoring by negative 5, we have to have that factor outside the bracket. And that's how we get this negative 5 times bracket 3s plus 2. Notice that the 3s plus 2 and the 3s plus 2 are identical. That means we could factor that out of the equation. So let's factor those out. 3s plus 2. And what's left? We have the s left, the s and the negative 5. So we have s minus 5. And this is our answer. Yeah, it's a little bit difficult. There's a lot of steps. So we're going to do one more for good measure. We'll do the second one. 6x squared minus 21x plus 9. Again, ask yourself, what if we can simplify this by dividing each and every term by a common factor? In this case, we can divide by 3. Therefore, we will get 3 as a factor, and we're going to get 2x squared. 6 divided by 3 is 2. And 21 divided by 3 is 7. And 9 divided by 3 is 3. So we still don't have a 1 leading coefficient. We have a 2. Therefore, we still have to use decomposition. And you have to ask yourself, what two values add up to the middle term, which is negative 7, and what two values multiply to get the multiplication of 2 and 3, which is 6. And then ask yourself all the possible factors of 6. There are 6 and 1, 2 and 3, but also negative 6 and negative 1, and negative 2 and negative 3. Which of these add up to negative 7? Negative 6, negative 1 add up to negative 7. So these are our values we're looking for. Negative 6 and negative 1. They have to be the same. This means that we could break this negative 7x into negative 6x, decompose negative 7, and negative 6x, and negative x, or negative 1x. We recopy everything else, the 3 and the 2x squared, and of course we still have to keep the factor of 3. Don't lose that 3. Then the next step is to factor by parts the first pair and the second pair. So you have to ask yourself, well, what two values, what factor can I get out of the 2x squared and 6x? Well, the answer is I could get out 2x out of this. What's left? I'm just going to do it on the side so you can see a little bit better. 2x squared divided by 2x minus 6x divided by 2x. And you'll get 2 divided by 2 is 1. X squared divided by x is just x. 6 divided by 2 is 3. And x divided by x is just 1. So we have only 3 left. And don't forget the factor. So we have 2x times x minus 3. When we erase that part, And we're going to ask yourself, what can I factor out of negative x plus 3? Well, the truth is that we really can't factor anything out of it except for one thing. We do not want this negative hanging around. So we're going to factor out a negative 1. How do we factor negative 1? Well, negative 1x plus 3, we're just going to divide everything by negative 1. And we'll get negative 1 over negative 1 is just x. And 3 divided by negative 1 is negative 1. Of course, don't forget the factor of negative 1. Notice, oh, I'm sorry, 3 divided by negative 1 is actually, 3 divided by negative 1 is actually 3 negative. What's coincidental and also very important is that you will always get the same factor of x minus 3 in this case. If you didn't get the same factor, therefore you did something incorrect. The very last step is to factor out x minus 3. Because x minus 3 exists in both of these areas, we could factor out x minus 3. So let's factor that out. And what's left? It's 2x and negative 1. So 2x and negative 1. And here is your answer.